Dames en heren, gaat u zitten. Hartelijk welkom in de gecombineerde zitting van de examencommissies van wiskunde en informatica. De examencommissie van technische informatica heeft de resultaten van het werk van de volgende kandidaten beoordeeld. Voor technische informatica, Engelen, Hendricks, Ladan, Martens en Rijshouder. Wij zijn een masterprogramma wat ook tweetalig is. Volgens onderwijs wordt in het Engels gegeven in de masterfase. En daarom wil ik ook de zinnen in het Engels herhalen. Ladies and gentlemen, I hereby open the combined public sitting of the Examinations Committee for Mathematics, Computer Science and Embedded Systems. The Examinations Committees for Mathematics, Computer Science and Embedded Systems have assessed the results of the following candidates' work. For Computer Science and Engineering, Abbas, Yafgal, Cor, Van der Linden and Son. For Embedded Systems, Chinta. For Industrial and Applied Mathematics, Kindo, Mangadi, Onuta en Schnier. Heren, kandidaten ingenieurs, u bent allen geslaagd voor uw examen en daarom krijgt u straks een diploma uitgereikt van het ingenieursexamen in de technische informatica. Dit diploma geeft u recht op het voeren van de titel ingenieur en tevens ontvangt u een Engelstalig diploma dat u het recht geeft op het voeren van de titel Master of Science. In totaal hebben we als faculteit voor technische informatica 1137 diploma's uitgedeeld. Uitgereikt moet ik zeggen. Uitgedeeld is niet helemaal hard gewerkt. Ladies and gentlemen, candidates Master of Science, you have all passed your examinations and will therefore soon have conferred your degrees for the Master of Science in Computer Science and Engineering in Embedded Systems or in the Industrial and Applied Mathematics. This degree entitles you to use the title ingenieur. In total, the department has conferred 40 degrees in Computer Science and Engineering, 1 in Embedded Systems and 22 in Industrial and Applied Mathematics. And I have to say, 1 in Embedded Systems, that is after today, because this is the first time that we will give a diploma for Embedded Systems. There are 2 candidates not here at the moment. Probably they are stuck in the traffic and hopefully they will come. And this means that we will start with the second candidate. That is Mrs. Chinta. And I would like to ask you to come here. Also the thesis advisor. Not only because you are passed your examination, but you are the first candidate for Embedded Systems in our university, and I would like to congratulate you with that.
Dear Engineer Chinta, dear Anuradha, congratulations on this day. Actually, I was not aware that you were actually going to be the first of the Embedded Systems. So this makes it even a more special occasion than it already is for you personally. I'll say a few words to explain about the things that you did in your final project. We came to be looking for find a project in an industrial environment, and we were doing actually a project, a European research project, together with Philips, and that's where you have been doing your project. Actually, by the time the project ended, the company was called NXP, which when it started, it was Philips. We've been looking at energy models for embedded components on handheld devices. And energy is one of the main restraining resources when we would like to build applications on these kind of devices. And one of so there are many nowadays developing energy efficient components which can actually do the same kind of job for instance, playing video movies on a handheld device using much less energy. But the issue is that actually you can do a lot more with energy, you can save a lot more energy if you manage to coordinate the way that, for instance, a handheld device works, but also with the party that is actually sending, for instance, video stream to this device. And one of the goals of this European Research Project is to enable such a system where we can actually coordinate between an application which runs partly on a handheld device, partly on maybe a server which is streaming the video, in such a way that the energy can be saved on the device, the quality of the application can be optimized. And in order to do that, we would like to be able to predict the relationship between the quality of this application and the energy that it consumes under certain parameter settings. And this is where you have worked very hard on scrutinizing a particular device with a particular implementation, actually of an MP4 decoder, in order to figure out what the exact relations are between the operations of the device and the amount of energy that it uses. You have, in order to do it, you've been measuring the behavior of these devices, and you've managed to extract simple models which predict how much energy a component will use, what the quality of that component will be in a certain parameter setting. You have, in order to do that, really got your hands dirty with real measurements, programs that have to be built for that equipment. Finding people that knew how these chips and how these systems actually work, and all the internal details that had to be managed in order to get those measurements right. But the end result are simple models which can effectively be used in a running system to find optimal operating points. Although one of the conclusions is that we'll probably have to wait for 1 or 2 generations of these devices before the changes in parameter setting actually lead to the kind of variations in